at least I think of it that way. As well, Limited Hangout, which is a performative cinema project as well that I work with an animator. Outside of that, I'm also the artistic director behind Rolling Riot, which is a spatial sound collective. Most recently during Fusebox Festival, which happened back in April, we did the Rainforest Reverb installation inside the parking garage downtown, where we created a 32-channel spatial sound installation filling up 5 levels of a parking garage. It was absolutely fantastic, one of the biggest projects I've ever been a part of. So check out Rolling Riot because we're going to be doing a lot more stuff coming up in the future. Now as well, outside of that, I'm connected with dadageek. I am a founding board member of dadageek, and I am also an instructor at dadageek as well. So dadageek, if you've not heard of us, we are one of the sponsors of Southwest Synthfest, but if you've not heard of us, we're an art and technology educational nonprofit. You can check us out at dadageek.com. By the way, we've got some really cool summer classes that are online right now that you can check out, so might as well just drop that. But I teach several different types of classes at dadageek as well, including programming in Maximus P, both visual and audio programming, as well as real-time visuals and projection mapping, say working in Resolute Arena, and then also Arduino basics, say like Arduino for an artist's purpose, right? Less so engineering, but more artistic output, and then of course spatial sound technology as well. And, of course, I should mention, I am also the creator of Countervolt, which is electronic music and tech art curation organization, which we run different types of events around town, and we're getting ready to team up both organizations into something much larger, so look forward to some of this kind of stuff that's coming forward. So, what I want to talk about today is talking about this hacking together immersive AV system. So first things first, what exactly do we mean by that? Say, for example, immersive. What I'm talking about when I say is that terminology gets thrown around quite a bit nowadays. What I'm referring to as an immersive installation would be something dealing with sound, of course, right? We're all coming from that background, so I'm not going to talk about that all that much. The rest of this list is more so what I'm going to be talking about. Video and image, that can be a lot of different things. There's a lot of different ways that we can talk about video and how that can be produced, as well as working with light and light interaction, and then also action interaction. So this would be something along the lines of action, be performative action, doing something, right? You can imagine all of our modular synths and synthesizers are not made to be very actionable by nature. So therefore, what do we do to make these more actionable? And then interaction, I have that listed because also this goes into installation pieces as well. So if you're installing something, where do you create that interaction to make sure that this is an immersive platform in some sense? So most traditional musical instruments, we think traditional as in the sense of like before the recording medium, are all intended and developed as a performative device. That is how we absorbed them back then, right? People performed them, people played them, so there was natural motion and action that was happening behind that. Nowadays, modern devices, of course, are not so performative, right? I love these devices, right? Like this TR-09, this tiny little thing, I love it. It's great. It's like this tiny little thing, and it makes these great noises, you know, and I really love playing with it. The problem is you need a magnifying glass in order to be able to operate it. It's so tiny. It's like the opposite of something that's performative. These were created as studio devices, right? To think of people that are inside their studio, ergonomically driven, in order to take up as little amount of space as possible. Now they do incredible types of things. People use them in performances all the time, right? But for the most part, a lot of these new instruments are not designed to be brought out into the performative realm. Now, of course, there are exceptions to the rule, right? Historically, we can say like theremin, right? Obviously, that is a highly performative device, right? So once again, an exception to this kind of rule. Buchla, whatever in the world was happening inside of his head when he was coming up with all this crazy stuff, right, as well, just kind of against the normal trajectory of what people were going for. Instead, this is what we're used to. Now I see tons of people utilizing, let's say, for example, like the Octotrack or anything like that, or a Model D live in situations, but these interfaces are tiny and hard to work with. So what do we do to bring this out? Well, we try to create an immersive experience for people, right? So you think of like these large-scale DJs and stuff like that that do these massive projection mappings and interactive lighting systems. Great, right? That's this immersive experience that everyone's looking for. But that's exactly to the problem. The problem with immersive AV systems is they are super expensive. There's absolutely no way that if we all pooled our money together, I don't know how much y'all make, but I know if we all pooled our money together, I doubt that we could be able to buy enough DMX lights to be able to make like a cool immersive experience, right? All the projectors that are required, the hardware and software is absolutely bonkers, right? Say for example, hardware side, if you want to work with video, typically you're dealing with projectors. Some of these projectors can cost up to $20,000 for an appropriate style projector. DMX lighting, which is industry standard. Some of these individual DMX lights cost more than my car is worth. Right? It's an absolute insane, they're amazing devices and they can do incredible things, but there's absolutely totally inaccessible to someone like me, an artist who wants to work with these types of technologies. Or say, for example, the software side of things. If you don't have, say, like educational discounts, which get a little bit nicer, right? If you don't have those educational discounts, the software side, say like Resolume Arena is like above $800, right? And if you want like the full Ableton suite, that's like what, $750 or something like that, right? It's pretty pricey. Tags that you're talking about working with this kind of stuff. So what I want to talk about are some of the different types of things that we can do to create more interesting, immersive interactions and performance installation without the incredibly high price tag, essentially, right? Trying to think creatively about this technology to do something a little bit different. So first things first, I'm going to be separating this into 3 sections: video, light, and action, right? The 3 things that I'll be talking about. Video being first, light a little bit later, and then action. With video, mostly going to be talking about a lot of the history that I've worked with inside of Cracked Ray Tube and the different types of things that we've come up with around that concept. So first things first, video. The thing that I want to start with inside of all of our Cracked Ray Tube background, going back to the very beginning, if you are just wanting to get into working with visual elements in real-time video in some way, first things first, remember, analog video is your friend. Right? Now, analog video signals can do, unlike digital video signals, they can do a lot. You can manipulate them, bend them, and different types of devices will still try to present themselves. Those of you guys that have experimented with any analog video stuff already know this, right? You can plug a lot of things into a TV and it will try really hard to represent it in some way, as opposed to a lot of modern technology, which is a little bit more gimmicky, right, in how it wants to display imagery. So, obviously, like a lot of modern video synthesis modules, they know this and they exploit this, right? And that's why a lot of them look very fantastic. The problem is, a lot of these video synthesizer modules are, once again, pretty dang expensive, right? So what are the types of things that we can do to play around with that? Well, once again, CRTs are your friend, right? The cathode ray tube is a, I would call archaic technology at this point, absolutely abandoned en masse, but is a very interesting object still, not only because of its cultural significance and its history, but also from what you can do with this device still to this day. By reigniting it with digital integration and digital concepts, we can do something really interesting with this old technology. This shot is me digging through a pile of TVs in Chicago at a Salvation Army. This was 2009 or 2010, I think it was 2009 is when I did that. This is, it no longer looks like this. This wall is completely gone. There's no more CRT TVs anymore, right? So these things are becoming more and more challenging to find. But this is where I got into this, right? When I wanted to start working with visuals, the first thing I said was, I need a projector, right? And I was like, oh, I can't afford that, like right away. And then I was like, what else can I do? I went to the thrift store, and just picked up a whole bunch of CRTs and started playing around with those. So it came out working with this, with these CRTs was more out of necessity to begin with than it was actually a desire to work with CRTs in the first place. So, one of the types of methods, or one of the types of things that came out of this, I should say, Cracked Ray Tube. If you've heard of Cracked Ray Tube is a real-time audio-video installation, performance, hardware hacking, and computer programming collaborative project between me, based in Austin, Texas, and my friend in Chicago, James Connolly. So James Connolly teaches at the School of the Art Institute of Chicago, which is where we first originally met, and started playing around with this type of technology. We both had a shared interest in one particular device, and that was the Sandine image processor. Have you guys ever heard of this thing? The Sandine image processor is a fantastic, unbelievable device. James and I both started developing interest in working with analog video based around this, this system. So it was one of the earliest patch programmable video synthesizers that was ever created. There were not many that were created around this time era, and a lot of them were all just handmade. They were designed at SAIC in Chicago at my school, and SAIC still has the largest, at this point, has now regained enough modules to have the largest system back in play again. It was created by Dan Sandine, hence the Sandine image processor, right here. And as it looks, you can see, there's hardly anything is actually labeled on this thing. And he did this intentionally, so there would be a lot more manipulation and experimentation behind this device. So I want to show you all an example. James Connolly has a really fantastic documentation laying out exactly how this system plays out. He's playing around with the Sandine image processor at SAIC. So here, check this out. I'll play it just for like first 3 minutes, but I highly suggest and highly recommend checking out his full video. It's absolutely beautiful. But we'll watch it just for a little while. It's the fan, it booting up. It's amazing. It just like whirs, right?
Explain it carefully enough so one would be able to walk up to it and use it. There'll be lots of details ignored. But by explaining it to some degree of detail to give a concept of how it works. First of all, it's a compact way of saying what it is to say that it is a general purpose analog computer, a general purpose patch programmable, meaning programmed by patch cables, analog computer, analog to distinguish it from what is normally called a computer, which is a digital computer, which is the kind of thing that does your bills and payroll and does information storing and retrieval and stuff like that. This is another breed of computer entirely called an analog computer. And it's optimized. What makes it different than most general purpose analog computers is that this one is optimized for processing video information, for processing television information, although it also can process sound or any other signal within some restrictions. One way to look at this machine, or for that matter, any process in the universe, is to distinguish it into a set of classes that have to do with inputs, processes, and outputs. And although this device has two modules which originate signals, the primary power is in terms of processing signals, taking signals in from the outside, processing them, and then outputting them to a monitor or tape recorder. The only external input that's being used presently in the image processor is the TV camera and it's actually being patched through the processor. I can control the gain over here. Go away, come back. But it is null processed in that there is no special processing. Input into the processor and output to the processor. Now the camera comes in along with the
Yeah, it's an absolutely beautiful machine in every sense of the term. It's amazing to think that this was created in the 1960s, and a lot of people are still trying to recreate these types of beautiful imagery. There's somewhere between the fluid, smooth edges of analog video, but there's the crunchiness inside of there because it's just like it's old and it's dirty and it's not well maintained. There's something that's very beautiful about that system. As well, you can see like when he was zooming out in the beginning, he has like the Mac G5 sitting there on the edge, showing that this device is definitely very much so modernized at SAIC as well. There's 4K capture cards and all that kind of stuff. So it's very much so a hybrid analog digital system at this point. So one of the things that James and I spent a long time, hours and hours, sitting with this machine and playing with it. And one of the beautiful things about it is not only just the machine itself, but the philosophy that came behind it. Now, this was created in the 1960s, and there was an early movement back then that Dan Sandine and Phil Morton collaboratively referred to as copy it right. So instead of trying to market the device, they just sold the plans. And the cost of the plans was just the cost of the photocopying and the shipping, right? So essentially, they were giving it away for free. This was a very early form of open source hardware systems, right? So the only ones that actually exist to this day are either ones that Dan Sandine built or other people just built by themselves because they asked for the schematics or they've rebuilt in certain ways. So example for them, one of Phil Morton's opening right here, talking about this, which I think is a beautiful statement. First of all, it's okay to copy. Believe in the process of copying as much as you can with all of your heart, which I think is a beautiful statement, and people should reconsider that that idea once again, right? It's okay to take someone else's idea and be like, that's fantastic, how did you do that? I want to copy it and then do something cool with it, right? That should be a system that we all celebrate and share these ideas so other people can say, yes, it's okay, take this idea and copy it and do something else with it, so that we start developing more and more and more ideas out of that. So the copy it right philosophy, of course, led to James and I pushing that same mentality when we created Cracked Ray-Tube. We started creating open sourcing all of our hardware schematics and diagrams, tutorials, and doing a whole lot of different workshops all over the US, as well, working with all of these different types of things. So if you go to, say, crackedraytube.com, you can find all of our tutorials up there. They're a little dated at this point, probably some of them are like 6, 7 years old even, but they're still relevant, right? You can still find them, and a lot of people are still referencing them. For example, one of the things that you can find up there is VGA video hacking. This is something that James came up with, just playing around with a breadboard and a broken VGA cable, essentially, right? He didn't know anything about electronics at the time, hardly anything. He just started playing around with stuff. And so he took a VGA cable, plugged it into his computer, and then cut some of the wires, maintaining some of the sync cables, and then tapped in analog audio signals into the red, green, and blue pins of the VGA cable. That in itself started to create some of the images that he was used to with the Sandine image processor. Say, for example, here's some documentation that shows what that looks like. Now here's the thing, instead of needing Sandine image processor, expensive modules or anything like that, you need a VGA cable from a thrift store and a soldering iron. And about maybe like $5 for the components that you can get off of Amazon, right? And then just an audio signal in some ways, right? You can have an audio interface if you want, but you could also just use anything playing from an iPhone or anything like that to create these visuals as well. So there's a lot of possibilities behind that, just playing around with this stuff. It gets better and better the more advanced kind of output that you have. Say, for example, an audio interface with high sampling rate, then it can do more complex things. But you can still get visuals just by doing very, very basic concepts here. Now, the VGA hacking was something that James was working with concurrently while I was starting to develop into the more so TV transmitting world. So I started modeling and developing small video transmitters that were based off of Tetsuo Kogawa's design, which they've been online for a very long time now, over a decade at least, much longer than that actually, maybe a couple decades. But he created these open breadboard design, open circuit design off of a copper pad, which is very common for a lot of different types of radio frequency types of circuits. You'll see this kind of method. What I would do is create these circuits that were intended to be video transmitters, specifically to transmit video to a CRT television. But if you slightly detune them, all of a sudden interesting things start happening, right? It gets that fuzzy image sort of look, right? So if we start playing around with what the input signal is, we start playing around with tuning this device in different ways, the output becomes incredibly interesting. We start to get these really fascinating results that look like this. Or say, for example, these kinds of things, right? Where we have these very beautiful, interesting textures, these familiarities like these lines, scan lines that go across, with these strange decays and all of these different weird ways. I became very interested in that. I was working with the TV hacking, he was working the VGA hacking, and that's how we just started Cracked Ray-Tube. This as well, the tutorial for all of this, doing the step-by-step for doing the video transmitter, is also up on crackedraytube.com, so you can find that as well. Now, one of my favorite hacks to do is with electromagnets. So when you're a kid, you take a magnet, put it up on the TV screen to get all the colors, right? That was something that I did quite a lot. And I started playing around with this idea of working with electromagnet. I'm not the first person to come up with that idea at all, right? Namjoon Paik has been playing around with electromagnets and magnetism and televisions for a long, long time, since the 1960s, and I was highly influenced by Namjoon Paik for quite some years. So I wanted to play around with this idea too. He and Abe, Paik and Abe, created this a video synthesizer, video system, that was referred to as the wobulator quite commonly, which is an electromagnet surrounding a CRT TV that then causes these distortions manually inside of it. So what's happening inside of here Lucky y'all, I brought a cathode ray tube, right? This is one of my old ones from Durastra, actually, that is burned out. You can see the front of it, all the phosphors are actually like torched, right? So this is actually what's inside the TV. What's happening inside of here, electron beam shoots through and then displays itself right here, a really high-powered beam of light, essentially. Think of it as a laser. It's not a laser, but it's just a really high-powered focused beam of electrons. Now, behind that, how we move it around is what's referred to as the yoke or deflection coil, depending on who you talk to. It's an electromagnet, right? So winding of copper wires, and that's it. The idea of this is that this places on top of here, and it guides the beam, right? It moves the beam around to different places on the screen to map things out. So normally, in its normal function, it writes out an image onto the screen right here, hitting the appropriate phosphors. On the phosphors on the screen come in 3 types, red, green, and blue, right? And it hits the appropriate one depending on whatever color is supposed to be displayed. What I do is I take an electromagnet and put it right about right here, right? What that means is somewhere in the path of the electron beam, it's diverted slightly. And what ends up happening is it hits the wrong phosphor. That's where you get the colorization that takes place, right? The RGB spread of that spectrum. But as well, you get this interesting folding of the image that starts to take place. What I'm doing is I'm taking an electromagnet, which I wind that happens to be around the same impedance as a speaker, so that I can just hook it up to an audio amplifier and crank a sine wave through it, right? When I put the sine wave through it, then it bends it in this sinusoidal pattern, right? And notice that sine waves look the most beautiful, typically the most fluid, right, and organic. Now, this one, by the way, this model that I built was a custom one that I built for Andy Lemon, who is of Teenage Cave Girl, the band, if y'all know them. This is one of those prison TVs, right? It was really awesome, so it's completely clear, right? So like no one can smuggle things in and out, right? So he had this and he's just like, I need this to be modified with electromagnets. And so I was like, okay. So so it ended up really nice. And there's 2 electromagnets that are inside of there to bend it in a couple different ways. Now, like I said, I was not the first person to think of this at all. This is Namjoon Paik's Magnet TV, which is one of his most famous pieces, and one of my favorite pieces of his, in which he takes television, sticks a stationary magnet on top, and lets it be an object on its own, which is a beautiful concept as well. He takes away all the interfacing icons on the front right here. So the idea is that you're not allowed to interface with this TV besides the magnet. That's how you're watching TV, by moving the magnet around and creating visuals with that. It's a beautiful idea. Now, eventually, me playing around with the TVs, while I was already building up my confidence quite a bit, opening up TVs and playing around with the insides, I started playing around with what can I do with this deflection coil. I pretty well understood the idea of how an oscilloscope works. I was like, well, a TV is not all that different. What can I do about creating this? Now, there wasn't a lot of information on the internet at that time about how to turn your TV effectively into an oscilloscope, but every once in a while, someone would talk about the fact that they've done this. So I started playing around with it. I started experimenting with all these ideas. Typically, the layout of your TV, like I mentioned, is like this, right? You have the deflection coil back here, the electron beam hitting the front. Now, what happens is the electron beam writes, doing a raster scan is what it's called, several lines all the way across, again and again and again, like a typewriter all the way to the bottom of the page, then it starts back up at the top corner again, and it writes all the way down. It goes back up and writes all the way down. So it's a grid pattern. When you snap that, say for example this connection right here, and you get rid of that, this is effectively what you end up with. Of course, when I combine them together, that's when we get these 3-dimensional types of images. But as I adjust this, say for example, I change the frequency to something that's more harmonic. There we go. There's 120 and 240. So they're octaves, right? And it starts staying still. If I just slightly phase them, right, we start to get this beautiful motion. So slight adjust in the same sense that there's 2 sine tones that are beating in and out from each other, right? Same concept, we get that visual association between that. And harmonics, of course, on top of that. Now, I went ahead and took this idea and was like, why don't I just do the other thing that I did with the electromagnets and stick that on top of there? So say, for example, if I then add an electromagnet that's being driven with a sine wave, that's when I can add color. That's when you get some really beautiful stuff that starts happening, right? Same concept, if I work with different frequency ranges, I get different results, right? Say if I go like really low, you can get some really interesting stuff right here. There you go. Now, of course, this doesn't just have to be a bunch of sine waves, right? Say, okay, so that's a kick drum from a TR-09, right? Only going on the vertical, right? So it's moving it up and down. But if I then say, for example, on the horizontal, do a slow frequency sweep across it, say at 15 hertz, it starts to actually function like an oscilloscope, right? We're actually seeing make sense? Right? So, is this or can this be this thing comes in? Y'all worked with Teensy before? Some people have, yeah. So this is a Teensy LC, which is actually a, you would say, is comparable to an Arduino, right? A lot of people have heard more so of Arduino. Arduino, it's a microcontroller board and software, so that you can actually write a code that then functions something in the real world. Teensy is an offshoot of that. The Teensy is a smaller scale form, which, as the name suggests, but the beautiful thing about it is that it is also natively USB, MIDI over USB capable. Meaning that if you plug this into your computer, you click your mouse a few different times in order to get it set up, and it will function as a MIDI over USB device. Meaning that you can just make your own MIDI controller or send MIDI data back and forth from, say, Ableton Live, or you can send things from a potentiometer button to Ableton Live very, very simply with this kind of stuff. So I wanted to explore different ways that I could utilize this MIDI communication protocol in order to create some lighting effects. That's when I got more so into what my work was with pulse coders. And a whole lot, there's the visual element, the video element, but there's a lot of lighting aspects that go behind that as well. So, for example, one of the setups that I worked with is with these string lights, these flashing string lights. Say, for example, if I take high-powered LEDs, which you can get for, what are they, I wrote this down, 5 of them for $8 off of SparkFun. If you want to get more of them, you can get them for a lot cheaper. If you go to Amazon, if you do a little bit of soldering to put on the heatsink and stuff like that, you can get a lot more for cheaper. But you can get a set of 5 of them for $8 already ready to go from SparkFun. This thing in the middle is the Pico Buck, which is an LED driver, which is used for high-powered LEDs. That is $16, and then the Teensy LC is $12. So inside of that system, you have a pretty cool flashing light unit if you want to work with it that way, right? You can send MIDI signals to a device in order to trigger it. Let's see if this is working. As an example, I have my pulse coder patch pulled up here, and let's see if, there we go. So, that's a setup that I use for like interludes in my pulse coder performances. So I have these strung up all around on like a table and things like that. This is just strings of these LED lights, right? This is maybe like $30 or $40 worth of equipment. And every time I'm playing this sound, there's a max patch that's creating this granularization of a lot of these like classic drum machine sounds. And then I'm analyzing the amplitude, and it's just sending out MIDI on notes, right? So I could hook this thing up, not to say a Maximus P or Ableton, but I could take straight MIDI input coming from a modular synthesizer if I wanted to as well, and translate that MIDI data into these lighting effects as well. So there's a lot of ways in which you could translate this kind of, just like that classic So there's 3 outputs of 3 of these strings, and each one is being triggered slightly differently, right? They're randomly alternating between each one, which gives it this variation inside of it. Now, another, maybe even more aggressive and effective form, is if you go to the hardware store and you get yourself a fluorescent shop light, right? One of these kinds. They're about, depending on where you go and how much, what kind you get, what model. Cheaper ones are around like $13, $14. You can get some more expensive ones for, $30, $40 or something along those lines. A SaneSmart solid-state relay board. Get this on Amazon for $30. And what this one is 8 channels. Here, right? 8 channels of alternating current switching that can be triggered from the 3 volts that come from a Teensy microcontroller. That means I can turn on and off blenders, toasters, whatever it is that runs on a full 120 volt AC with these small little simple boards, which is really fantastic. So that means I can send MIDI signals over USB to my teensy that can then trigger these individual relays that can then turn on and off really big kinds of stuff. So say, for example, let's see if this is working. There you go, right? These big kind of flashes, right? So you can use a lot of these different types of instruments. So let's see. There's different ways that you can program this as well. So let me load up a different song. That's all my MIDI notes that are normally going to all my MIDI controllers that are hooked up, that are not hooked up. So Max doesn't know where to put them, so it puts them to the internal MIDI tone generator, the piano. All right, so say for example, you can program this to flash in different rates. That's more of like a randomness kind of flashing that's taking place. So when I trigger it, it's actually opening up a random generator that's giving it a glitch effect. It's not glitchy at all, and in reality it's actually highly programmed, but it's intended to look random and glitchy and faily-ish, I guess you would say, right? I've utilized this quite a bit in installation practice as well, and I want to show you all an example of an installation I made in which I utilized this method. I did this one in just last year, 2018. So all the flashing here, imitating like a system that's failing, is actually highly programmed and randomized inside of there.
March 21st, 2013, $3.22.
And then it scares the hell out of people, so everyone's up, right? Yeah, it's cycling through stock quotes, and as the stock quote goes down, it gets worse. The algorithm responds by becoming more chaotic. You'll notice that I have exactly 8 of those lights. That's because of that 8-channel relay board, right? And all it is, the max batch is just sending out MIDI note on and off notes to trigger all of these different lights. Now, another setup I use this for is with Pulse Coder. A little bit more aggressive. This one was at a warehouse rave, which was a lot of fun. But this will give you an idea of the kind of music that I like to make. There's that 909 again. Yeah, the dude in the Apex sweatshirt's really digging it. So I won't expose y'all to that right now because y'all didn't sign up for that, right? But come out to some of my shows and you can see that in person. It's a lot of fun. So outside of lights, which hopefully y'all will get a chance to play around with that in a little bit as well, how to translate your action on stage into something that is has a sonic or visual reaction, right? Like I said, some of these devices that we work with are teeny tiny, and they're not very performative whatsoever. They're great devices, but they're mostly efficient and ergonomical. But small-scale devices, meaning efficient controllers, produce small, efficient movements, which is not what people want to see in a performance at all. They want to see radical and dramatic types of movements. So, things you can do, very simple, right? Say, start by extending your controllers. This is also a teensy microcontroller that I specifically designed for my TR-09 drum machine. The idea behind that is that I can just turn on and off different types of values. Of course, I did make the knobs bigger because I wanted to twist them, right? And the knobs are tiny on this thing. But people can see what you're doing which is kind of important. This is just a small thing, right? Just a small addition inside of there. But when I press this, and people see that a kick drum starts, people know that you're not just checking your email, that you're actually trying to perform and do something up here, which I think is significant on its own, right? Now that's something very simple, but of course, it can get a lot more complex. This is the new media art duo Ariadne, who are some friends of mine. They're from Brooklyn. They performed at one of the countervolts a while back. They do real-time visuals, mostly like programs like Touch Designer and stuff like that, but also have a lot of really beautiful, granularized, crazy types of sounds, as well as live operatic vocals. She's an insanely good singer as well, but they wear these instruments that were custom made. Now, of course, they have the rolly light pads on either side, which are pretty cool, but that's a little expensive, right? But really rad. They actually have the sound responds to them. And sorry, the rolly light pads respond to the sounds that are being generated. So it's like an additional visualizer, which is cool. But they have springs on these boards, which are actually sound responsive, but they don't generate springy sounds. They use them to play, but they trigger granularized vocal samples and things like that, right? So they can pluck it or play it like a guitar or move it around or stretch it in different ways, but it creates this, this interaction I think is super, super fascinating. As well, someone like Letitia Sonomi, who created the Ladies Glove, which has multiple flex sensors on it. This was created back in the 90s. She started with this, which is absolutely amazing. She's been working on this project for a long time. And then one of my friends, Marco Donnarumma, who is crazy, insane performance artist, but on top of that, he's created a system called the X-Sense, which is small medical-grade microphones that are intended to be used for listening to super low frequencies of muscle movements inside the body. So essentially, like, you know, when you put your fingers on your ears like this, and you can kind of like hear creaking and bones and stuff like that moving around, right? So all those kinds of sounds are actually picked up. So he can perform by just flexing and moving around in these really interesting ways. He's all tatted up. It looks really cool. But he moves around in all these different ways, and it's actually picking up on his muscles. And he can control his computer in different ways by moving around and creating all of these different types of sounds out there. Highly performative, and at this point it is motion activated rather than just buttons and knobs, right? You're actually moving in space to create some kind of sound. That can be done a lot of different ways. The project that I do that quite a bit is with Durastra. I perform this every once in a while around town, but I just came back from New Tech in San Francisco where I performed this as well. This piece was actually at Collab Projects back when they used to have their house in the field and all that stuff, so a while ago. So this is an installation that I had made, and this is a performance that I did in front of it. Quick example. So inside of that system, what do I have going on? Two types of sensors. Force sensing resistors, FSRs. This would be like, say, what's behind your, say, for example, a pad on a drum machine or something along those lines. When you hit it, it's sensing how hard you hit it. Sometimes there are these things. As well, I have a SparkFun 3-axis accelerometer, which I believe is about $14, right? An accelerometer is slightly different than a gyroscope. Gyroscope does sense motion and movement, where am I positioned. An accelerometer kind of does that at the same time, except its intention is to measure acceleration, going forward or going backwards, how far you're moving. The thing is, how it functions, essentially like a weight and a whole bunch of springs, right? So when it moves, it goes, whoa, kind of wiggles, right? And so it knows where it's moving, essentially. If I turn it onto its side, the weight naturally pulls down. That's gravity. So it thinks it's moving in that direction. So you can actually still utilize it kind of like a gyroscope. But what's cool about an accelerometer as opposed to a gyroscope, I can then take my TV and I can throw it around or move it in different ways and get interesting responses. You can't do necessarily with the gyroscope, which is just like, where am I facing? The accelerometer is like, how hard are you throwing me around, essentially. So an example of what that looks like. Here's some excerpts from some of this is at Collab, some of it was a pop-up performance at Currents New Media, and then some of it is some studio documentation that's really, really old. Moving in different directions will create these different sonic and visual responses. Effectively, what you're seeing on the screen is what you're actually hearing at the same time, for the most part. Currents New Media, which is also another festival I highly recommend checking out if you ever get the opportunity to head out to San Jose. This is a pop-up performance right in the middle of the gallery. Popped up here. So yeah, and then some of the more slow, drony kind of things you can create with it as well. So a lot of possibilities inside of that. And I've been working with that technology for a long time. One of the new things that I'm really interested in, the last thing I'm going to mention, is kind of like the future, right? Where a lot of this interaction is going. Xbox Connect has been around for a long time, right? And the reason why no one uses it is because no one has made a really good game for it, right? So it's this incredibly advanced technology that's kind of just been sitting there, right? It's really expensive if you want to buy them new, but if you go to GameStop, you can get one for $40. Now, it used to be that this was not an accessible medium whatsoever, and it took a lot of computer programming in order to actually get some useful functionality out of this technology. But if you pair this with something like a technology like NIMate by Delicode, which you can download, it's a fully functional demo that just has some restrictions on it, right? But I think the full version is only like $40, $50 or something, right? What this can do is, say, on a Mac even, which is really great, you can download this software and you communicate with the Xbox One. The Kinect for Xbox One. So the types of things that you can do with this is all of this really interesting skeletal tracking. Now you might say like, oh, okay, cool, you can make like this thing follow your skeleton or move around or something like that, but like how does that tie into my modular synthesizer, right? Well, the cool thing about NIMate is that it outputs MIDI, which is incredible, right? So that means I can actually track the position of my wrist, my head, my body, my feet, anything along those lines on a three-dimensional axis, and I can output MIDI 0 to 127 data to another software on my computer, or it could be out to an audio interface or MIDI interface that could output to a piece of analog hardware, which is quite amazing. So I think there's a lot of potential in that I haven't seen a lot of people experimenting with yet. And I think it's one of the next things that I want to start trying to play around with. It's just gotten to the point that it's accessible and affordable. So I highly recommend jumping into all of that. So the Xbox Connect, if you get the newer one, it is $40 at GameStop. It's the cheapest place I found it, which is weird to walk into a GameStop, ask for a Connect, and then just wanting a Connect to make art with, right? And then also, NIMate is free, but you do need a power supply for the Connect, which is, I think, initial like $30 or something like that. You can get it on Amazon. So pretty cheap entry point. So yeah, that goes through all of these aspects. Any questions about any of the types of technology or anything along those lines, or more specifics on where to find information about it, I'm more than happy to answer your questions. Otherwise, as well, you're more than welcome to come up here and play with some of this stuff while we still have a few minutes. So, any questions right now?
What are the sensors you're using on the side of the TV?
Yeah, so there's the force sensing resistors, which is like how hard I push on each one, right? Which then control these like swells of sound. But then there is just switches and buttons. And what I do with that is switch between like my different states. So like this changes the functionality of like what the bass frequency is, and then I can change how each thing changes. It changes in different ways. So changing between different like preset patterns, and I can improvise inside of that.
Another question. The last thing you're showing, I'm not an Xbox user. You need an Xbox.
You do not.
You don't.
Yeah,
So
you just need a computer, and you need that NIMate software. You do need a USB 3.0 connection on your computer. That is required. Will not work with a 2.0 connection. But most modern computers that come out nowadays have 3.0 connection.
So there's a lot of high voltages involved here.
Yes.
And anytime you ask guys about stuff on the internet, they say, if you're not a trained professional, don't mess with it. And then it's like, how do I become?
It's because you have to. So I came across a lot of that when I wanted to get into this, right? And I'm like, I'm not a trained professional, but I'm just really, really, really curious, right? And so I'm willing to figure this out. So I did my research, and I figured out exactly what I'm supposed to do to appropriately handle this kind of stuff. And eventually I became an expert on it, right? Now I feel like really confident inside of a television. Unfortunately, it's not a skill set that is applicable today, but it's still something I think is useful. So yes, there are proper ways to discharge television, for example. Televisions are incredibly dangerous on the inside, significantly, potentially more so than what's just coming out of the wall, right? In different, more complex ways, because they can hold charges and things like that. But I have in my tutorials step-by-step instructions on this is this, this is this, this is this, this is how you appropriately discharge a television in order to work with it. So I say, like, if you don't feel comfortable with it, don't do it. But at the same time, if you're going to do it, here's how you do it properly. So
Did
yeah.
you say like maybe mess with? You could do the VGA stuff with like a flat an LCD screen.
It's a good question. Certain ones are smart enough to be like, this isn't right, you know, and then which is annoying with new technology because it like goes blue screen and it's like, oh, trust me, you don't want to see this, and it's like, no, I do want to see this, right? But while CRTs on the other hand are just like, yeah, I have no control over what you're doing. I'll just display whatever. So VGA computer monitors that are like CRTs usually work really well, and they have deeper colors anyway, a deeper contrast. But you can get them to work still on like the older flat screen VGAs as well. As long as they have proper sync, it'll work. It'll accept just about anything. Yeah.
You were talking a lot about like taking the RGB values and changing them and stuff. But there's an audio component to a lot of these distortions. So I was wondering how does the audio fit in the analog system?
Yeah. So say for example, say like on Durastro, which is my performance. All the audio is being generated in Max, it's being synthesized in Max, but it's being controlled by all of my control elements. And then that audio that you're hearing is also the same audio that's driving the electron beam. So it kind of represents it itself as an oscilloscope, so there's actually a relationship between the audio and the visual.
So
right?
like early on in your presentation, you had like the waves going out and up and oscillating. Where was the audio there? Was that just
that was coming from my computer, from Max Patch. Yeah, so it's just creating sine waves, but it could be literally any audio source. Right, so all it is going through is just out of my audio interface, becoming analog, and then just going to an analog amplifier, right? Which I highly suggest actually digital amplifiers, Class D amplifier board. I highly recommend those because you can get them for like $50. They're about like this big, and they have like 6 channels on them or something like that, or 6 or more channels. Really useful. Yeah.
Question. For the Max patches that we're using, are you using pretty much just the visual programming, or do you actually have to get down to like gen and code?
I don't work in gen very much at all, but I would say to the point in which I get pretty deep and dirty, I feel like I'm essentially programming, right? I might as well be working in gen. Say for example, like that's just a simple patch, but if I go to like my pulse coder patch, right? So I've got like clip launcher here, which is all these sub patches. I've got one aspect of it here that I can break down into it right here. I can break down into it right here. That I can break down into it like my groove object and things like that, right? There's all of these different subsets inside of here, right? I just keep breaking down, essentially. So getting to a point where it's like, sometimes I might as well be, right? But I'm still technically, it's all just Max on its top layer. Yeah. You can do a lot with just generating sine tones in Max, working with these TVs. Even if you don't know much about Max, you can just make some noise on it. You can do some pretty interesting stuff. Once you start getting to modulation, FM modulation, frequency modulation looks fantastic on these things. AM is a little noisy, a little more odd harmonic content, which kind of looks a little rough. Anything more complex, like granular synthesis, just looks like a total mess and noise, right? So things that are a little bit more sculpted harmonics tend to look the cleanest on these oscillographic systems. Any other questions?
Actually, I got a follow-up.
Yeah.
How much does that TV weigh that you're throwing around?
It weighs a lot. Every person that tells me that has at one point in time blown out their back, they're like, it's coming. They keep telling me that. And I'm terrified of it because I'm sure it is going to happen at some point in time. Yeah, it's really heavy. I've gotten really used to doing it though. The tube that's inside of there has been replaced many times. The newer ones are a little bit lighter. They're still, like CRTs.